Good evening, Hazi Mohammed sir. Sir, we'll be starting the session within a while, sir. Within 2 minutes, we'll be starting the session, sir. Sure, sir, sure. Sir, I guess now you will be able to speak, sir. Good evening, everyone. We request all the faculty fraternity to please turn off your videos except our resource person. Good evening, everyone. This is Leela Prasad, working as an assistant professor in Ramchandra College of Engineering. Welcome back to the second day of our faculty development program on disaster risk reduction through sustainable infrastructure. Yesterday, we delved into fundamental principles of disaster risk reduction and sustainable infrastructure, gaining valuable insights into their significance. We, from our side, hoping that session Dr. Balu sir and Dr. Murali sir was very insightful. And today we will examine the application of soft computing techniques in hydraulic engineering. Let me take the opportunity to introduce our esteemed speaker of our today's session, Dr. Hazi Azmatullah. Good evening, sir. Session of faculty development program. Let me introduce the profile of our esteemed speaker. So Dr. Haji Azmatullah is a professor of civil and environmental engineering at the University of the West Indies at St. Augustine, Trinidad. Uh, Sir has a degree in civil engineering from SKD University, India, and master's degree in water resource from Devi Ahilya University, India, and a doctorate in hydraulic engineering from Indian Institute of Technology, Bombay. Sir's research interests and activities are in the fields of physical hydraulic model studies and hydroinformatics. Sir has been a member of the editorial board of several high-ranked journals such as Water Science and Technology and Water Supply, Journal of Pipeline Systems Engineering, ASCE, from 2019 to 2013, and Dam Engineering journals. And Sir has a publications of above 100. And uh, Sir is the associate editor of Journal of Hydrology for the esteemed journal Elsevier. So that's all about a brief introduction of our esteemed speaker of today's session. Now I'm handing over the session to Dr. Hazi Mohammed sir.
Good evening.
Good
May I
evening, sir.
audible? May I audible?
Yes, sir. Yes, sir.
Thank you very much. Today I am going to speak application of soft computing techniques in hydraulic engineering. My screen is visible, sir? Hello.
Yes, sir. Yes, sir. It is
Okay.
visible,
Thank you
sir.
very much. Thank you very
So,
much.
can you put the
Thank you.
slideshow, sir, so that
Yes, yes.
both the hands.
I will put slideshows now. Now slideshows. Is that okay? Hello.
Just a second, sir. I'll be checking.
Yeah, yeah. This is slideshow only. Okay. No. Yeah. Before I want to start this lecture, I was working in Central Water and Power Research Station, Pune, from 1998 to 2006. Before that, I was in National Water Development Agency, New Delhi, under Ministry of Water Resource, Government of India. You know that one, you all aware, interface in water transfer. Then by the time my chief engineer was there, Kurana, he suggested me to join Central Water and Power Research Station. It is the biggest laboratory in India. I will show you this one later. I will go. You can see here picture. This is Dhauliganga Dam spillway. Okay, so any project, you know, all aware, so we have to do some model studies before existing. This is 1 is to 70 geometrical similar model. Okay, you can see here right hand side there is a chute. Okay, chute flow here, see, with operating 3 gates. Okay, you can also see upstream side there is a gutter here. So when dam authority came, so my boss, Dr. Kasturia, he was the joint director, he informed there will be maximum possibilities this slide of right bank upstream side, it will collapse. But he don't listen to us. He was a very arrogant chief engineer from, you know, National Hydroelectric Power Corporation. What he say, when nature is going to do, why should I waste my money? Okay, so you can see why I am showing this. You can see this picture. You can see left hand side, this is model, this is right hand side. Imagine, see, I left India 2006. This is
Sir,
2012
sorry
or
to interrupt
13.
you. Sir,
Hello.
sorry to interrupt you, sir.
Yeah,
Your
yeah.
slides are not visible, sir.
Not moving.
Yes, sir. Yes, sir.
Not moving.
Yes, sir. Yes, sir.
Why is can I go
Can
like
you
this
play,
now?
can you play the slide
Uh,
slow, sir? Slide
No,
slow.
I played the slideshow only. Then I
Okay,
don't
sir.
know
Please.
why. Now you can see. Hello.
No, sir. No, sir. Please
No,
present it again, sir.
no. That's
Please
why
share your
some.
presentation again, sir.
Yes, yes. Okay, okay. Wait. Let
Yes,
me
sir.
stop this, and
Sure, sir.
I will share again. Yeah. Wait. How come this one gone completely? Okay. Now you can see here window. Okay. Hello. Now can you check and let me know if any problem?
Uh,
Yeah, this one may
yes,
be
sir.
good, so that so that I can see. Okay, let me start again.
Yes, sir. It
Okay,
just
now
started.
can you see visible, right?
Uh,
If I go
Yes, sir.
PowerPoint mode, some problem I
yes, sir.
really don't know.
Mhm.
Yeah, I will go PowerPoint mode. You want PowerPoint
Yes,
mode?
sir. Please start the slide, sir. Sorry.
Yeah,
Yes,
yeah.
sir. Yes, sir.
Okay. Okay, so why
Yes,
this
sir.
kind of all problems? You all aware, as a structural engineering, there is no problem. Whenever you come to interaction of hydraulic structures, there is a big problem. You can see many disasters, even bridges, spillways, dams, culverts, failures. Failure rate is very high. You know. Now you can see. Can you see the slide? Hello. Someone should interact with me, please. Are you able to see my screen? Hello?
It's not changing, sir.
Yes, sir.
The
Hello?
first
Sir,
title sheet
again,
only.
the same problem.
Same problem? Okay.
Yes, sir. Yes,
Okay.
sir.
Wait, I really don't know. That's why
Sir,
I came to.
if it is a problem,
Uh,
do you want me to present
yes,
the
please.
slides,
That's
sir?
what I asked. That's why I asked. That's why I asked. Okay.
Okay.
Please,
Sure,
someone.
sir. Sure, sir. I'll be
Please.
sharing.
Yes. Someone,
Sure,
please
sir.
help
Sure.
me. If you want, I can share. Okay. Yeah,
Sure,
share,
sir.
please. That's why I was requesting. I came to university for you, but I really don't know. I'm really sorry. The internet here.
No problem. No problem,
Okay.
sir.
Yeah.
I guess now it is visible to all.
Yes, yes, yes. Excellent. You were speed very high here. We have very bad. Okay. So here today I'm going to some typical applications. Okay. Can you move to third slide, please, so that
Sure,
I
sir.
can
Sure, sir.
explain. Okay, what I was telling, my first degree from G. Pullaredi Engineering College from Karnool, Professor J. Ram Reddy, who wrote engineering hydrology or simply hydrology. Then after I moved to Anna University, but I could not survive with the Tamil culture. Then I moved to Devi Ahalja University, Indore. I started, after my degree, water resources, I moved to National Water Development Agency, New Delhi. So one of my chief engineer, Dr. Khurana, who served in Central Water and Power Research Station, he asked me to move Pune and simultaneously I should do PhD. That's what his understanding. Why? There is a someone raised their hand. I don't know. Um, there is a Sankosh project, working under WAP courses. There is a dam spillway, Sankosh, and the northeast one, some projects. So that time during design section, Central Water and Power Research, Central Water Commission, New Delhi. So that time they advised me to go Pune and work here. You can see this slide. This is the Dhauli Ganga project. Now I really don't know whether in Uttarakhand or Uttar Pradesh. There are several states like Andhra Pradesh and Telangana, all changed now. I really don't know which state now. Maybe we understand Uttarakhand only. Okay, this is Dhauli Ganga Dam spillway. 1:70 scale model. You can see here. So whenever this kind of jet in Rockfield Dam, either you can provide this one chute either right hand side or left hand side. But you can see here upstream side there is a problem. In geometry, whenever flow coming hitting this one. Here that time my joint director informed National Hydroelectric Power Corporation director, technical director, it may collapse. He don't listen to at that time. Okay, can you move another slide, please?
Sure, sir.
You can see here, your left hand side. You can see that time. This is me. This is my boss, Chimpigar from Karnataka. This is my team. The working, I worked very hardly with them. Whenever you go other state, other country, already there is several local feelings. They never ever listen to me. Okay, since I don't know Marathi that time, I was very new at the age of 22, 23. I started. You can see here, 2006 I left India. This is I think 2012 or 2013. So you can see, imagine here. That's why this is the greatest advantage. See, whenever nature, if you disturb nature, there is something possibility. You can see exactly what my boss told that time, upstream side, everything. So another thing here, during my design time, I recommended that time 3 spans. Then after when I moved to Malaysia, then it come to only 2 spans. I don't know about his one. Normally, you can any three spans. You can provide one almighty flood. One you think for safety, Indian standard. Bureau of Indian. They will recommend one more chances. Okay. So here you can see upstream. There is a power intake. See, before power intake, everything collapse here. You can see here. So this is the complex. Okay. Another thing you can see downstream. So that time this deflector I designed that time. Okay. So the original figure you can see both training walls there here. Okay. Chute blocks and training levels, and here what we study, especially whenever you see design, you have to maintain certain pressure. You can see here rooster tile also you can see in front of pier. Okay. And also your banks always we see rock foundation good and all everything. Though that's why this is the hydraulic beauty of hydraulic structures, and especially water very dangerous. So anything can collapse. Okay, go to next slide, please. This is about Dhauli Ganga, Uttarakhand. Okay. Yeah, this is Salal Dam spillway. I think 1987 or something. Then the Prime Minister. You can see the beautiful dam in Jammu and Kashmir. Okay, Salal Dam spillway. This one, see. You can see. So you all aware. See here, upstream. No, sir. Don't operate. Go back, please. Go back, please. I want to explain something. See here. See, upstream side is very calm. See, like laminar flow when static end. Downstream there are, see, the spillways are operation. Okay. Now you can see after inauguration of our prime minister, late someone. Okay. Next day, what happened? See here. Next slide, sir. Okay, now we can see the fog is going to more than dam height. Okay, when this is speech and bucket. Okay, normally so energy dissipation. Either you can see, I will show Srisalam dam will be also. Okay, so what will happening here? See, all your right bank collapse. Then that time prime minister was very angry with whoever designed this one, maybe NHPC or something. So this is the situation. You can see all water color downstream side. So this is the greatest disaster and very blameful for certain engineers that time. Okay, go to next slide. So what was the flood? See here, 1,50,000 cubic feet. Okay, same thing. So he was very depressed and very anger, and nowadays all very difficult and huge money. Okay, you can see all spillway. Why here? See, this jet should be. So suppose you are in water, swimming pool or somewhere in water. If I throw something, it won't hit much. Okay. So the idea, we need to design plunge pool here. Okay. Next, please. Next slide. Okay. See what happened after 24 hours. So right hand, nothing. Everything color change. Everything. Okay. This is about Salar. So what you need to do? So you need to design a plunge pool. Okay, plunge pool. You need to the preformed plunge pool. You need to design. Okay, that one actually expensive. But what to do to save? Otherwise, what will happen due to high velocity jets every time? Okay, a lot of turbulence. Then it will affect to your foundation, dam foundation. Ultimately, after few years, dam will collapse. The same thing happening now in our Srisalam dam. Okay, go to next slide. Okay, here what is the problem? You can see, you all aware the jet is not moving. See, always we all aware in high school physics intermediate we studied. Whenever you do Diwali crackers, your horizontal range. U square sine 2 theta by g. Theta is the lip angle 45 degrees. When sine 2 theta sine 90 degrees 1. So you will get maximum range. Okay, that is the thing. Okay, so this is the greatest example every year. So sometime one day you really don't know what is happening underwater.
Hello.
Correct? Hello. Okay, next slide, please. Okay, so I was working with I was working with Iranian water resource agency that time. You can see always you can do perfect modeling. Whenever you do this kind of hydraulic modeling with the glasses and all, so you can see flow phenomena. You can see one of the figure here. Okay, so see the horizontal jet moving more than 2 meters. Okay, so whenever your jet is far and whenever it is impinging, so your dam should be safe. Okay, main structure. Okay, next slide, please. Next slide, please. Okay, so what is happening? See, you all aware why? In dam there are two components. One is spillway, another is non-overflow section. Overflow section, non-overflow section. Why? We need to dispose flood water in excess of reservoir capacity. See what is happening now. Whenever upstream, I totally forgot. Nagarjuna Sagar before Srisalam. Okay, they will release that time. Whenever you want, they won't release. That also, I worked at that time, Almaty Dam and all in 1997. Whenever Karnataka say we are losers and Andhra Pradesh say loser, that called Technical Advisory Committee. I really don't know till they solved or no. Another issue, burning issues, all aware, our Kaveri and all. Okay, so to control discharge over spillway, using gates only. That's why you all aware recently in Telangana, what happened to one gate. Okay, what barrage I don't know. Then the government BRS or TRS, I don't know. So this main aim, you need to provide some energy dissipator downstream side. Otherwise, there is no safety. Then efficacy of energy dispatch downstream of spillway. That's what in Srisalam Dam. Okay, and also I am taking consideration here schism bucket. Okay, otherwise you can provide stilling basin also, but there is very huge, expensive. Why, all concrete cost and all. Okay, yes. So next slide, please. So why this all need? So this is, you can see upstream side reservoir level, second crest level. You can see here radius of the bucket. This one what I was telling, radius of that. So India, you can see Indian standard codes. That one they say trajectory bucket. America they say flip bucket. Okay, clear? In the England or some other places, schism bucket. Okay, three all same. So these jets see with this is small discharge they take discharge unit discharge. This is H1 is reservoir level between upstream level to downstream level. This is called your energy level. Then also you can consider here depth of tile water level. So this is always whenever you go whenever this kind of bucket. So if you sufficiently all aware advanced water resource engineering, the final year students you might have taught. Then another thing, so whatever there, even though how whatever you provide due to this high velocity jets, even big boulders that will become pieces. Okay, that's what you can see. Even Narmada Sagar, this one Gujarat one, that time, when I was studying in MTech, my master's engineering, we visited, my boss showing due to this water surface profile, even huge concrete blocks flopped. You can go and check Narmada Sagar, that time. And also you can see here, this kind of score occurs downstream of the bucket. Okay, the another thing to alternate to prevent this uncontrolled riverbed banks. So we have to be very careful now anytime Trisalam dam. Why? So you can ask here, they provide 30 degrees angle only 30 degrees for Trisalam dam, which is located now. I hope same Karnool Jilla only, otherwise if they have changed name I really don't know. Okay, so two alternatives. One is pre-excavated plunge pool to save this one here range. So for this you need location of this this jet and where maximum score depth will occur, and also you need to know width of score and depth, so that you can preformed plunge pool you can design. Another thing, rising tile water level by constructing sufficiently downstream. Okay, here somewhere. So there are only two operations. Okay, this what will happen, several. Okay, can you go to next slide? Several investigators, this one almost 100 decades. Okay, so how estimation of score and classified under four general categories. First is theoretical analysis coupled with laboratory investigation. That's why this is the very oldest laboratory in India. Okay, this one based on UNDP. That time anyone joined, they go America, do University of Minnesota, they have collaboration, they do masters. And another one, theoretical analysis coupled with prototype observations. Okay, I have collected 98 dams. Okay, another thing, empirical based on prototype observations. Okay, the fourth one, laboratory experiments. Okay, next slide please. So that time two researchers, you know yeah, here. So factors can predict depth and pattern of score hole. Okay, so first is discharge intensity. This one upstream level of another Parvati Dam spillway, which I consider for my PhD also that time. And head, I show you just now. Okay, so several people they consider, this is the head belongs to between, this is the difference between upstream level, this level to tile water depth. But some other researchers I will show you. Then tile water depth, this is very important. This all factors that no one considered. And also lip on of the bucket. Why I show you? Why we Trisalam Dam will fail, going to fail. So several research. Another thing I told you, if bedrock is very strong, we trust and nothing will happen. But you think something, but God will think differently. Okay. The another thing, rock quality designation. This one no one done, and also I also don't get so much data, and also rock mass rating. Okay. Okay. Several investigators developed, to predict score depth. Varanasi, I told you almost 100 years, and also another Damle who worked in Central Water Power Research Station, our ex-boss. Okay, another thing, some Chinese and some Europeans, Martins. Okay, there. Okay, next slide, please. What they have considered? Only discharge intensity and head. Yeah, you can see here. Okay, so in case of Ukai Dam, again, sorry, Gujarat. Okay, so Virness formula, okay, providing or predicting that time with this small formula 18 meters, but actually observed 27.4 meters. Imagine what will happen. Another thing, in case of Ukai Dam, this one, in case of Rana Pratap Sagar, I think this one in Rajasthan, okay, observed score 24.7. Okay, now another beautiful example, Kariba Dam in between Zimbabwe and okay, that one Zambezi River, Wellness formula give, okay, 42 meters. You can see, you can go to Google and check the observed score depth 70 meter. Every 10 years you can see if dam height 120 meters more than going. So this is Bureau of Indian Standard, which is very similar to USBR, means small dams, United States Bureau of Reclamation. Okay, so what they have made a mistake, they consider only two parameters, two factors, discharge intensity and head. Okay, that to head they have considered. Okay, Damle, in case of Damle, he consider not tile water. He say, can you go back, please? Can you? I want to show in spillway. Okay, some research. Can you go again? Back the spillway profile. Okay, go back. Hello, one more. Okay, so
Okay,
different
sir.
people. So yeah, now one more, the profile one. Where rectangle, yes, this one. So the different researchers see, I consider reservoir level to tile water level, the difference. So I consider as head, but in case of Damle, he consider until here. If you go and recheck reservoir level to is the lip level. Okay, he consider or the head. Okay, this is the main difference. So which one is correct and how, we will see now. Okay, okay, you can go. So you all aware now, see, very clear. So what will happen? This one greatest, whenever if dam failure, so now they will not hesitate to send to jails. I believe my father when working in Guntur or some, then after 10 years or something, anything, any water tank, anything, directly they send to engineers to jail. That's why in concrete or steel, that's why 150% or 300% factor of safety they will take. But here, whatever safety you take, sometimes there is no choice. Disaster means disaster. That's all. You can, in case of, you can see Salal Dam spillway. Okay, sir, go ahead. Here later I will show this one, Parvati Dam spillway, another one. After him, how vortex will take. Okay, next slide. Okay, so this is the situation. So that time, okay, whenever see this kind of problems, so what is exactly, so any Navier-Stokes equation, any equations, even though CFD modeling my students tried that time, but only they can provide only depth. Okay, that's why whenever they were data like this, that time, actually this neural networks used in electrical engineering, why voltage flexible. So whenever your data like this, and I try to plot in between score depth and discharge intensity, score depth versus head, but there is no the pattern or something, some trend. So the very highly randomness I will show you after. Okay, go ahead. Next. Next slide. So that time you can see in neural networks I used that time. So several. Okay, slowly. Whenever see, you can see this kind of things, even share markets. So now you are all aware how to, buy news and all. In India stock market went up, went down, and there are several factors. Even your elections and all. Whenever they're predicting it will go down and all. These all no need theories. Okay. So here some input layers I provided my factors, and also this one hidden layer means input multiplied by weights plus bias, all aware. Whenever some ministers or anything influence, you need to pass him only, you need to give A grade, otherwise you will be transferred, otherwise they will remove. Okay, so another thing, output. Okay, this thing here, whatever the target, this one called error propagation algorithm. That time I used a German one, Stuttgart neural network simulator. Okay, I used same two parameters. Okay, next slide please. Some algorithms I will show you. Okay, So cascade again means it's keep on adding this one way. This is the beauty of then until reach your one means error. You need 10 meters core depth, it will give 10 meter, but very slow and but very perfect also. Okay, error. Okay, next. Okay, this one another one radial basis function network using this one. Okay, next. It's all give only one output. So that is the problem that time means I want like continuously when my model I operate physical model, I will get score depth, width, length or location so that I can design my plunge pool. Okay, next. Okay, you can see here fuzzy logic. So how our washing machines work is very similar. Means automatic. Here see several 5 layers. Fuzzy logic means if you go any hotel and all, food sometimes good, hospitality good, but infrastructure very bad. How you will react with giving tips and all when customer satisfaction. So fuzzy logic means neural networks plus fuzzy logic. Okay, this is called ANFIS. In MATLAB that time very powerful. Okay, next. This all drawback this neural networks. They never give any formula to for this one to designers. That's why that is the drawback of like black box models. So I use nowadays I use gene expression programming, which gives me which gives me you know which gives me some formula so that designers can design. Okay, depth, length, width. Okay, it's all some okay, next please. How I changed sentiment analysis. Okay, next slide. Okay, but you tell me, are you believing model data or prototype data? But still, only difference is, you know, only difference. Your grains, the same boulders you cannot use, right? In model due to limitations. Okay, okay. So some objectives I collected. Okay, next please, width, length, and okay, can you off camera, please? I got distraction. Please, audience, off their cameras, please. Okay,
We
We
some
request
request
all
all
the
the
participants
participants
to
to
turn
turn
off
off
their
their
off, please.
videos.
Okay, so how this one? Whenever you run model, your model. So here running model, then extraction of knowledge with the trained models means weights and bias you can catch, and then you can use same matrix in next time. So what how these models works? You got 100 experiments you done and you collected 50%. Yes sir, stop here. I will show you 50%. Yes, very nice. 75. See 95 experiments I conducted. 75 used for training pattern and testing or validation 20. Okay, is that correct? So here I use discharge intensity and head, tile water depth, lip angle of the bucket, radius of the bucket, then particles. This is very important. Then my outputs are what? Length, score, depth. Okay, so you all aware why disaster means risk. Risk means 1 minus probability, means probability of failure. You can see here this photograph. This is Parapati Dance Spillway, very beautiful location, Himachal Pradesh. You can see three gates were operation fully. Why? Here see I will show you this upstream view also. Why this all North India? We need to generate power. Okay, next slide please. Okay, here see downstream view. You can see exactly. So very laborious and sometimes you need to have patience. Okay, with your labor technicians, your mason, your carpenter, whoever designing, even with mechanical. You can see chute here. See long chute. Okay, with two piers. Okay, two piers, three gates operation. Okay. So here see you can downstream you are measuring water level and with these gutters. Okay, next slide please. That is the beauty of 3D modeling, physical modeling. You can see upstream. Yes, please. This one power intake. So what happened? How see design very complex. Even I and my boss made mistakes. Here this one full reservoir level upstream. Okay, normally when how you operate full reservoir to minimum drawdown level, then only after that you all sediment water. So your turbines will get damage. That's what my present student doing such a analysis. Okay, so okay, next slide please. Upstream. I don't have video clippings, otherwise I would have. Yes, see this one before. So you need to then this one my contours. Imagine from here to here almost 2 meter in model only. So that one very beautifully your maximum score depth following here occurring here. Okay, somewhere. Okay, and also see geometry. Okay, and also here I use only 50% only discharge. So another thing you must aware, either discharge, this one maximum or 50% or 25% different. So you need to do all. That's why that is the beauty of model. You can do anything in model. Once this model is ready, you can get operation. How much discharge? One is free flow, another one is gated operation like fluids. Okay, this all you can see here. This one called breast wall spillways. Okay, all NHPC latest technology. Okay, okay, next slide please. Yeah, you can see in model only. See here what is happening. Here everyone observe. So it's hitting to right bank. So how they don't want to change dam design. So what that time that time really, that's why we are very brilliant. So you cannot change this one. Correct. This is hill or anything. You cannot change. Water is hitting here. So what that time I suggested and my team. Okay, we can change dam axis, right, little bit, so that you can avoid your that we won't hit your right bank. Otherwise what will, after a few years hitting, it will destroy. Okay, then another disaster. Okay, so that's the time I did this one. Okay, next please. Okay, you can see this one. So now something. Okay, if your jet also moving due to dam axis, so only we have suggested little bit dam axis if you change, so that it will. So this is the idea. Sometimes all brain game. You can see here right hand side. So all piezometers were provided. You need to here very dangerous. You all aware cavitation what P minus PV by rho V square by 2. Those who teaching fluid mechanics and all. So very very important. Another thing, this water level should not more than your training walls. And also you can see rooster tile. This called rooster tile. Okay, okay, two roosters, that beauty. So let's go hit and some like spray it will. So in air only your energy. Okay, this called. Okay, next please. Now I want to show you three. Okay, so now you all aware this one. In second year level we teach all in fluid mechanics the two. Okay, depth of storage, function of discharge intensity, head, bucket bucket and lip angle, depth of tile water level, and bed material size. These are some common. See, we not using any sea water, anything. Same river water only, and density of sediment. Okay, this is all common. Okay, by next slide please. By using of this one raw variables I considered, and this one by using a Buckingham pi theorem. This one your fault fraud number, not fault fraud number, just fault number. Since why here depth of tile water level I consider. So okay, this one all relatively. See here, no dimension. So whenever your depth of score relative to your tile water level, then at least some guidance you will get. Okay, so you can if you are in water, if outside if I hit something it will go hit. If suppose you are in water, it won't hit that much. Okay, okay, next please. So same data I have considered. I have developed three equations that time. 2004 I have published in American Society of Civil Engineering, AC hydraulic engineering. You can see here. Okay, you can see here relative score depth and location of score depth relative. You can see maximum means fraud number is very important, and also this one head also very important. You can see here reverse coming minus point. Why minus? Okay, negative. It's showing negative. Okay, relatively. Okay, but still it is important. And also you can see very important bed material size in model. That is the our drawback. We will consider 2 mm 3 mm sand. Use a sand. Okay, I cannot put the big boulders, right? And also lip angle of the bucket, very 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 important. You can see 0.9. So you proved, right? This is the multiple regression I used. Okay, least square fit. After fitting this one I used lingo that one what origin package, and you can solve any now solvers came. So in case of location of score you can see maximum pressure. This one 10, almost 10, and head and lip angle of the bucket you can see. That's why, correct. So in physically also I explained, and also if you give sine 2 theta sine 90, the jet will go very far and it will hit. So that your dam should be very safe. Agree? Okay, next please. So in case of width of score, I got some, see here, lip angle of the bucket negative. means we cannot. So lateral energy dissipation. Okay, so correct, this one, this direction I'm going. Simple formula, like in our high school, rate of change of momentum equal to force. Correct. So that is the thing. Okay, next please. Then you did some regression. You all aware correlation fitting means it's very sensitive. That's why in American journals they asked us to use root mean square error. Okay, the simple formula observed versus observed score depth predicted one. Okay, so I did all very laborious. Okay, next, then also mean absolute. Okay, next slide please. Average error and average absolute deviation. Is that okay? So like this. Okay, next. That time I published only this kind of three formulas in each journal. Okay, you can see correlation coefficient is perfect and average error little bit. Okay, mean absolute deviation you can see and root mean square all are acceptable with regression equation. Okay, next slide. You can see whenever you plot with observed versus, so there are still, see here, in case of high values, still outlier. This one perfect fit. This one you are observed. This one you are predicted. Okay, so correlation questions, but they don't ask. They will ask R square. Correct. Coefficient of determination. Okay, next please. In case of score depth. Okay, then in case of score width also. Okay, agreed. But in case of C low time, all underlying, under predicted or over predicted, under predicted. Okay, so I told you, I show you some negative coming and lateral energy dissipation very difficult since my flow and my hit going and not laterally, right? Directly hitting, not like this side. Okay, next. In case of location, it's working very perfect. Next slide, sir. Hello. Next slide. Yeah. Sorry. Go back, please. Location, you can see a very high correlation. Why? See, it's very proved, right, with lip angle and all. But still, some range of data, some, okay, under prediction and some very far outlier. So you can draw a line, 10% line, 20% line. Okay. Next. Okay. Okay, you can see again same slides. That's why we went whenever problem poorly defined. So that time I used neural networks and nowadays gene experiment program. Many others came. Okay, this is the one design. Okay, next slide please. Same thing I'm showing. This is a very beautiful dam. Same. You can go ahead. Okay, same examples. I want in the introduction I shifted some slides. That's why. Okay, this is our Srisalam dam. Okay, now come back to see two input. This one I collected. Collected real data. See, I have tried to plot with the discharge intensity and score depth. Okay, that time they said T. Okay, this one real dams I collected. You can see if I try to fit anything, nothing, highly randomness. Okay, highly randomness. So same way training I used means to derive regression equation, and also I used 75 patterns, 75 data sets. Okay, next. Okay, in case of head, see head also same. Okay, so you can imagine this much head is really some dams. I also that time. Okay, and also score depth you can imagine. See maximum reached. It is maybe Kariba Dam. Okay, it's Kariba Dam height 120 meter. Okay, 120 meter. It's reaching now 90 meter. So this is get a greatest headache for hydraulic engineers. Okay, next please. That is the difference between structural and this one. Structural one, once you follow course, you take factor of safety, you are good to go. You are fine. No harm. Okay, here typical first initially, as I told, real data sets I use discharge intensity and head, two input nodes. Then okay, you can see here weight matrix and this theta here, this one bias. Okay, input multiplied by bias plus weights through some transfer function hidden, then you will get output. This one typical neural network sets. Okay, yes sir. Next please. So two inputs, one output. Okay, that time I used only this one Baper algorithm, cascade correlation, radial basis function, and ANFIS. Okay, That clear? Observed score depth versus predicted score depth. Okay, you can see here, initially that one, all soft computing used. Another one, this one traditional formulae, this one traditional formulae. Okay, so still there are much under prediction. I show you already, right? In case of 4 dam, Ukai Dam, Rana Pratap Sagar Dam, and all. Okay, next my formula I will show you. Okay, here this is my formula, very similar, and my with my formula only 0.77. Okay, discharge intensity. You can see the these powers. Okay, so still increase. Yeah, this is the correlation coefficient. Okay, now we can see the comparison of errors. Okay, in case of see feedback network giving very good results. Okay, then neural network feed forward cascade correlation means each hidden nodes you are adding during after your training. Okay, but here imagine only one output. Okay, then radial base function and phase, this one traditional marker formula, this one author means me. Okay, these are the errors. Okay, so this one I published in Journal of Hydraulic Research in 2006. Okay, you can if you want the coordinator, if ask, I can send links, or I will provide my papers. Okay, okay, next please. So this is about real dams. Now come back to your model data. Okay, okay, what I did here, so prototype only one I used. Okay, it's called depth only, one available output. Okay, now you can go next please. Here training 75, this one my physical models. You can see this is the raw data before dimensional analysis, means become model one. Yeah, raw data. And also here see continuously this model how works. I can give you depth of score, I can predict location of score and width of score. But I told you as a drawback, you cannot get any equation in like black box. What use? Tell me, just for publication. But your designers, they will critically comment what is the use. If you give training matrix, weights and bias, nobody will happy. Correct? Nobody will happy. Nobody will happy. They will question. So that time even I run and predicted that one weight matrix, but no use. Okay, next. You can see next please. Okay, you can see here this one fraud number, this one grouped means non-dimensional depth of score relatively with the tile water level, relatively location of score, width of score. So here relative head, bucket radius, then fine, lip angle. The lip angle is very very important, right? Okay, is that okay? Okay, next please. Okay, so these are the, you can see here my inputs in raw model 1, 6 inputs, 10 hidden nodes, 3 outputs. Okay, you can see in case of RBS and all is very very fast. See, I used MATLAB that time, even 3 3 seconds you put run, you will get answer. Okay, I wrote code that time. Okay, okay, next please. Okay, in case of model 2, you can see here only 5, so that your matrix size reduced, reduced already. Okay, you can see RBF even 2 seconds. Is that correct? Okay, next please. Now here, okay, you can see here. So this paper, this result I published in AC hydraulic engineering. Still I did regression analysis also with this. Okay, next please. Okay, these are the comparison. Okay, with all trained models. Okay, regression model last one. Okay, I will show you equation. Still it's going to be good. Yeah, this is the here, these are the results, model 1, model 2. Okay, different, very laborious regression equation. You can see here a error negative means under prediction or over prediction. Negative means over prediction, right? Okay, okay, next please. Yeah, you can see this model I suggested one. Okay, weight matrix also, in case of even your computer. Okay, next please. Yeah, something significance of inputs. Suppose if I want to lift this one, if two fingers are if taken easily, correct. If all variables there, like unity, unity, okay, like sensitivity, each parameter. Okay, next if you go criteria, okay, each each output. Yeah, yes, very good. Here think with two inputs, how my error is changing. Okay, then three inputs, then four. So each time sensitivity I remove and I operate this one raw variables. Okay, then next one grouped one means with dimension analysis one the inputs. Okay, next one you can see errors. Next slide, sir. Yeah, you can see here first proud number and head, this one common, very important. See how errors. Okay, so not slightly still, if all consider all parameters, so that in future any design it won't do any mistake. Okay, next please. Okay, you can see here. So I proved this also. That's why my supervisor, everyone happy. So whatever I show you in during regression type equation, the powers exactly will match if you go back. Okay, next slide, next one, next slide. Okay, you can see here. So I show you right almost. We'll see now. Okay, so that's what I proved. Okay, means the neural networks or regression, whatever. See, if you play with inputs and weights. Okay, weight matrix. Okay, next please. That's why you see always weightage, right? if you if you have power, if you in positions you are powerful. Correct, that's why it's power law. Okay, parametric studies. Okay, keeping all inputs but one as a constant. Okay, in model how do, that's why it's possible in mathematical. Every time you damn means dismantle your model and do another one, keep on change means very laborious, right? That's why in mathematical modeling very easy. Okay, next. Okay, and now you can see trend, correct. Whenever you your head very high, the score depth how it go very high, correct, like that. See the red color one, even discharge intensity. In case of, you can see bucket radius, what is happening. So whatever trend I show you, I got you, correct. Agree? Yes, you can see rising trend, then convex, and also you can see blue one d50. If you have your boulder size very high, correct, you can't get more score, right? Yeah, very hard rock. Okay, next slide please. We will see yes, you can see here what I will do. Sometime you go to your students, your technicians, very I have that time some my old technicians. Okay, he say he's experience, no need to do, directly put values. That time very difficult, right? Sometime any erroneous data negative. Okay, or measuring data anything wrong and all, so it's called 10% error, 20% error. How your correlation coefficient vary, this called perturbation analysis. Okay, next slide. You can see in tabular form, very clear. You can see here, see if 5% mistake, 10% mistake, 20%, see how changing. Okay, like this. Agree? Correct. In case of all three, why I need to design plunge pool. Okay, this one in case of model one. Go to model two, please. Okay, here this is the matrix. See, I totally become mad, half mad. That's why once you do engineering, PhD in engineering, almost mad. Okay, go back please one time. Go back one slide, sir. Yeah, here see this matrix. While typing only, I see here. Okay, how it's changing. Okay, okay, okay. Next please. Each node and how hiddenly in black box. Okay, this is the thing. Okay, I did it for only 10. If many nodes, imagine, so headache, right? That's why all data science. Okay, next. This is in case. So then what will happen neural network? So that's why I assume, okay, no, we use fuzzy logic also. Fuzzy means if then else. Okay, so your coordinator contacted me, I always available online, then so that otherwise very difficult, right? Before telling, see anything, any data, we need to normalize how in schools and also everyone same. That's why your school uniform you treat your teacher. No. So here also same, normalize, denormalize. Okay, 0 to 1. Okay, next please. Next please. Yes, here see the problem here only not like neural network here one only one output at a time. Okay, so these are the my five inputs as we discussed. Okay, then and also two rules. Okay, next please. Okay, okay, here see input member thing, then rules, then output member function, and see always correct rules, all rules and regulations correct, if then else. Okay, simple. Okay, next please. You can see here. So what is happening here? You get highest correlation coefficient 0.97. Very good. Next, yeah, same as we always observed. Okay, score length time very perfect, very high. I think, but still I have some outliers. Yeah, so under prediction. Okay, this also. Okay, next. Always we cannot give the perfect, right? So some conclusions I made that time means what I am trying to say. So USBR they used two two inputs, same thing. Indian one I really don't know the then I asked Professor Khare also at Turkey who taught me in indoor. Why don't you change, why not consider my equations and all. I really don't know how they work. And still no change. Okay, next slide please. Okay, next. So these are the that time yield. I will show you another one in case of bridge pair and all. Okay, why always see means uncertainty. Okay, these are the inputs and grouped, that's why means whenever you taught them your students, what is the importance. See, all my 60 papers based on Buckingham pi theorem. Agree, huh? Okay, next please. Okay, next. Okay, 3% accuracy. These are some results. Okay, okay, next. Yeah, if anything happen at Switzerland Dam, please let me know. Okay, okay, some contribution. Okay, yeah, next. Okay, so in case of anyone want to do, so you need to collect rock quality designation data and rock mass rating. So once you all have engineering geology one course, right? Maybe you are geologist. Okay, latest soft computing. Then after with time change everything now, right? Like machine learning, that this nowadays very advanced. Your students also very advanced. They know how to use Android mobiles and all. Okay, so they can easily grasp and they use good softwares. Okay, next. They will show you the world. Okay, so that time these are the contributions. Okay, which slides are now we are in. Okay, next please. Yeah, okay, next. Still there, still. Yes, here I want to show. So the my main aim, so I planted with origin again. See, so your damage different story. So downstream means building dam. How many years it will take due to advance. So this is the gated flow. Gated means upright. So this is the your bucket lip elevation 2130. This is all I'm talking about. Parbati Dam spillway, Himachal Pradesh. You can see once you see elevation, you all know aware about. Excuse me one second. You all aware about the elevation Himachal. Okay, plunge pool proposed model study. So you need to provide some advance like this. So each 25% discharge. So my maximum discharge 1850 meter cube per second. If 50% 925, correct? If 25% 462. Okay, this is the water profile and score profile. You can see him. So where it what jet is hitting and how much score. So although you have tile water level, maintain train water level. Okay, so 20 meter, this one see your apron, correct? This one apron only. This is your bucket leap. So this is the story. Okay, in case of see along central spillway. Okay, so you can provide your plunge pool like this elevation. Okay, so this also costly only, but what to do? You need to consider dam safety. Otherwise, this will be greatest disaster, and for engineers another headache. Okay, next please. Okay, what you can see here, ungated flow means like free flow. So where jet not much moving, correct, correct. You are 160 meters, this one from bucket lip. Okay, okay, next place. So you need to design like this plenty pool. Okay, okay, some background I give, why we are going for this soft computing. See, everything in life risk, correct. I got job in I cleared in UPSC exam, Indian engineering. Then also I left India, I went to Taiwan. Then the director, she don't want to give, means not allowing that time. So I take my risk and I now moving the world. Okay, so anything risk. So this also same, correct. Anything you are dealing with nature, we don't know nature, right? Nature always, nature, correct, nature. That's why my Professor Reddy was telling, random means this all nature is stochastic, correct, deterministic and stochastic. So whenever you design any flood or anything, the probability risk. So as a hydrologist or as a hydraulic engineer, so risk factor always. That's why you can take 25 years, 50-year return period. Sometimes if worst, so you do something, you think something, God will think something, and that is the headache. That's why this is a random type, random inputs, random outputs, how to mapping. That's why this soft computing intention is, especially I told first time they used in 1980 1982, that time electrical engineering, your colleagues, you did since voltage up down, they then we adopted in civil engineering. Okay, so you all doing like rainfall runoff, like black box mapping. Okay, in hydrology complex and dynamic, not that much. So nowadays you all aware, right, our problems. You are not allowing any rivers. I don't want to comment since you want to put in YouTube. That's why some headache. So you are disturbing nature. Nature not disturbing, correct. Nature can live without us, but we cannot live without nature. Okay, so this is the non-linear problems, how to solve. Okay, sometimes even complex Navier-Stokes equation cannot solve. That's why they put a huge price. Okay, complex relation between variables. Okay, through soft game techniques model and trained properly. Okay, this is the background. Okay, next slide please. I will discuss the pairs. Okay, some advantages and some, see here, possible risks. Okay, that's what, correct. Protection, everything. Why see, why what for we are doing, correct, for global safety, correct. Loka kalyanam means, if in Telugu, if I want to tell, correct. Okay, and also optimum, you don't want to spend all your money, correct. Suppose any dam, I don't want to tell that government, this government. Okay, so so cost will very drastically increase, right, if you will not finish in particular time. And also rapid, correct, estimation relationships, several variables, correct. Everything now cost of living very high. Okay, and also sometime what you need to do, you can see in case of concrete time, during I studied 30 years ago. So concrete, some ultimate stress, working stress, some will give warning, some not. Otherwise just everything. Okay, life. Okay, possible risk associated. Okay, okay, next slide please. Okay, then sometimes see, this is the that time neural network they used artificial. Okay, this one. Then also support vector machines. Then gene expression, I like this one, gene expression program. Why? It will provide some equation, some like very similar to your regression equation, so that your designer will be happy, you also happy. You are like I don't know, Andhra Pradesh, irrigation department or someone, if you provide, they will happy. Okay, next please. Okay, so this is the some objectives, hydrologic applications and implementation. Okay, sometime another thing is everything computing and all, with the age and advanced, so many things changed. Okay, okay, next please. We have time, sir. So this technique I discussed already. Okay, why we need to do, we need to do physical and we need to capture all this kind, okay, this kind of techniques. So physical model almost laborious, but this one physical. I cannot provide here the glass one and all. That time only they very, very, that time how much my salary was? 8,000. Yeah. When I was in Delhi, that time only 1,600, 5,000, and Pune came 16,000. When I left India, in Malaysia, my salary 13,000, 30,000, but Indian government increased 60,000. They say I'm mad. Okay. Okay. Next slide. Next slide. Okay, so this one, why reliable, robust, okay, salient characteristics, and you need to capture non-linear relationships. I told why, otherwise will need to face very high risk, correct? As I told, fewer parameters used, sometimes I have, okay, we will do, and also you are dealing with real world problems. Okay. Okay, next. So how it works, how my brain sharply, since Somus are always available, so my brain, anytime I can contact him. Okay, so this is the typical how dendrites and axons work, correct? How your mind trained, correct? How vision. Okay, next. Input layer, hidden layer. Okay, next. Okay, then these are the each neuron means information, data, and several transfer functions you need, this one, that time, tansig, and several I used and all. Only thing is you need to operate 0 to 1 Stuttgart net, but I go inside, I make sometimes 0.2 to 0.8 maximum normalization. If we do, means once before and after, normalize, denormalize, after that then you will get original answers. Means the that's the very important during training. Okay, next please. Next please. Okay, so among all, very slow, this background algorithm very good and all, then very fine, means you no need, don't have any risk. This one very good. Okay, next please. Something I will show in bridge pair also. Next, these are the neural network algorithms. Okay, the comparison part 2. Yes. Okay, next please. I also used state discharge, always very important, correct? This one, state discharge curve, means that one very important for us, the water levels. Okay. Okay. This one, ANFIS I used for defugifying. Okay, two parts. Okay, next please. Yeah. Yes. This is the typical. If then else. Perhaps when we study in seventh or eighth and all that, I forgot that one. Permutations computations in Telugu, the Samutulu or what, I totally forgot. That time we say why we need all studying this one. Correct. Even matrices. We used to ask our teachers why we need this one all. Then now I realize that after few years, this is the importance of this, correct? If then else and all, well, in life, and this also very conditions. Okay. Okay, next please. So genotype fuzzy inference model, this one, layer 1 2 3. Okay, I don't want to go detailed. Okay, next please. Every node. Risk or less risk. Okay, next, part 3, support vector machines. This also all, this one all, sometimes they don't give, they will give only trend. So what is the use for designer as a hydraulic engineer? They will not happy. So if you tell this much hidden and all, no one happy, right, with machine. Correct. Next. Okay, next please. Okay, now this is the I like this one. This is the software. If we have, anyone have data, please try to contact me. So we will do, a good collaboration. Now presently I must inform you, I am the professor and head of the department in this university, my department of civil engineering and environment engineering. Okay, so genetic algorithms, you all aware. So my master time I do for reservoir operation genetic algorithms. Okay, that time I use linear programming. Okay, lingo and goal programming I used at that time. Okay. Okay, next please. This one, this is the gene expression programming, GP or GP. Okay, this are the sometimes if some sir want, again my session I will explain this all. Okay, next please. It's simplified flowchart. Flowchart is stepwise algorithm. Initial stage, how randomly. This one very easy. Within 5 minutes you will get answer. But how you got it, need to know. Okay, next please. Okay, now you can see here, one of my student in Malaysia, he want to do pipeline score. This is the typical river in Malaysia. Okay. Okay, now you can see next slide. Okay, next slide. Okay, next. This was stream flows and all. So okay, next water quality. It's all several everything in risk. Okay, I want to show. Yeah, yeah, yes. Next, please. Next, please. Okay, next, please. Next, please. Yes, you can see the another one here. Grass pollutant traps also. I will show you that one. Coded below pipeline I will show you. Here I usually know this one. You all aware why flood is happening in cities especially. So we'll drink water and throw somewhere, then it will chop up sewer. Then flood came. If sewers not properly flow, all flood water, then you would say, I don't want to comment anything. Then you want to put. So I never know actually. North Andhra, I don't know. I belong to Rayalaseema, so I never know. That one very unfortunate, which I saw, the floods. Okay, next please. Next please. Next slide. One grass pollutant traps. Okay. Okay. Next please. Yeah. Okay. This all data. No, not this one. I want to show some photographs. This one MATLAB new perform technique. He copied again. I think my student. Okay. Next. I want to show. Yeah. This green expression programming. Next. Yeah, this one. Yes, this one I developed in lab. In Malaysia, when I was university in Malaysia, this is government university. Score below pipeline. Okay, that's also very headache. Very great failures, and sometimes pipeline boop, then very difficult, especially oil pipelines and several risks. Okay. Okay, next. Typical. So he do in straight model, and also he do in physical model. That one. Next, some conclusions. Yeah, this one you can see. So each with this beautiful slide will conclude. I don't have that one Malaysia one. I need to show where my student used score real model pipeline one. Okay, this is the think we have time. Okay, this is the thing. Okay, sir, Somu sir, can you type this one? Okay, before if you have in Kariba Dam score, can you show this one? Okay, how to type? I cannot type. Why? Hello, can you allow me to type? Kariba Dam spillway score. I need to. Yeah, Kariba Dam. I think
Okay, sir.
the
I'll
I'll
try
slides
try
are
to
to.
do
full,
that.
right? Yeah, you can close that one. You can close and go to any Google Kariba Dam spillway. Kariba Dam spillway score. Then share screen, sir.
Sure,
Sure,
sir.
sir.
Sure.
Sure.
Score. Okay. You can share. I can type here. I can't type.
No,
It's
sir.
not allowing me to type. Otherwise, I will share my screen. Okay. I will type. Okay.
Sure, sir.
I will type Kariba Dam spillway score. Okay. Okay. Any image I will show you. Okay. Yes. Yes. Sir. Can I share my screen now? Only screen. How? Can you
Yes, sir. You
allow
can
me?
share, sir.
Yeah. You are not allowed. That's why you're not
Just
allowing
a
me.
second. Just a
Okay.
second.
How to? Okay. I want
Sir,
to,
now
at
you
least
will be
I want to
getting, sir.
type here to
Sir,
you.
now you
You
will be
allow? Yeah.
getting all the
You
things.
allowed. Yeah. Yeah. Click that link and share. Click that link, please. Yeah. Click that
Sure,
link and
sir.
share. I want to show
Okay, sir. Okay, sir.
the Kariba Dam spillway. Otherwise, if you allow, I can share.
I'll be sharing, sir.
Okay. Yeah. You share. You share. I will share, sir.
Sir, I have
You want me to share?
shared, sir.
You share. Okay. Thank you. Ah, go to images. No, not that one. Yeah, yes, only images. Yeah, yes. The first one, first image. Zimbabwean, yeah, Zambezi River. The first figure, sir. First one. See, each year, how score depth going, see? Okay. No, No, sir, not research
Leela
gate,
sir,
only figure. Go to
show the
images,
picture file.
the first
Show the
image,
picture.
first image. Yes, yes, that one image. That's what. Oh, that's going to show like this. Okay, okay, no
Yes, sir.
problem,
It
no
will
problem.
be
I
loading over
understand, I
here, sir.
understand.
Research kit means you will get paper. Actually, you
Yes, each
open the
year,
image.
how score depth going see here. That's what I want to show.
Direct it is one.
That's all.
Okay.
Yes, yes, that figure. Otherwise, second one, any other only figure you can't see. Yes, that's fine. Yeah, yes. Just zoom in and show only that one.
Yes.
Widget, sir, widget. Yes.
Sure, sir.
Otherwise, this also okay. The last one, all everything. Yes, yes, yes. Thank you so much. Thank you so much. Thank you so much. See, in case of 1962, you can see years. Okay, so this is the burning issue now for them. That's why so many times I really don't know. They might have, they say, get approval, dam removal. Correct? You agree with me now? Hello. So this is the
Yes, sir.
situation. See. That is the another thing you can don't share here. Many bridge failures, because of score and abutment. You can go to my Google Scholar. You can see any papers. Many. Okay, this is the greatest our risks. Whatever you design, still there is a risk. Okay, sir. So I finish in time. Hello, Somu sir.
Sir, thank you very much, sir. Professor Haji Mohammed, sir.
Thank you. Very
And
my student don't want to, still he's sleeping. Actually, I requested him. We want to provide you exact, but I still I believe I still our examples. I whatever you want me know examples we
yeah,
have we have
definitely.
covered. So what are the
Definitely, sir.
challenge?
Definitely. You have shown light, you have thrown light on various soft computing techniques like neural networks, ANFIS, support vector machine, genetic algorithms. Really, these are the present day technology on which entire world is running.
Still see, yes.
Even in biology
Uh,
also, they are using artificial neural networks, whatnot. Everywhere, these latest soft computing is being used. And thank you very much, sir, for showing excellent examples and information that I hope definitely participants will think in this direction. These soft computing techniques can be applied to different even risk problems like score, failures, dams, etc. Okay, and so, sir, I have one small question, sir, Professor
yes,
Haji
please.
Mohammed.
Yes, please. Yes, please.
Sir, for these neural networks and these ANFIS and all, we need enormous amount of data.
No,
So,
not like that. You can see, right? I
yeah,
take only see 93 dams only, not much 95. Correct?
okay,
We will not get much data, 95
yeah,
and all.
but the
But range
2020,
is important, sir. Range.
uh,
See, now why I show Kariba Dam especially, so maximum score depth, 120-meter dam height, score depth you are going almost 90. Means imagine, means how
okay,
much disaster will happen if dam collapse. What will happen? Tell me. Government first they will call, right, the chief engineer or who. Correct. So not much that much statistically 30 they will say. Okay,
okay,
30 will say, but range always important, right? So
yeah,
suppose you taught me motorbike and car, but you cannot ask me drive airplane, right? Correct.
yeah.
So
But
that
anyway,
limitation there,
yes,
limitations and maximum. Yeah,
but
training.
we
Yeah.
need to validate the models and all. No? Actually, for validating, at least the enough data will be available.
Yeah, that's why see how MATLAB people will do.
Okay,
Suppose you have 100% data. Suppose say you have 100 data sets. 50,
okay,
what I suggest, 50 for training,
okay,
25 for validation, 25 for testing. Okay.
okay, okay.
Which you not used in training time. Correct.
Yes,
That's why
yes,
I collected data for Srisalam Dam, but I will use another one, Polavaram or any other one, but
Okay.
similar, right? We need to
Yes.
use similar. At least data range. But you are telling 2 lakhs cusecs are this much, but you are using for 4 lakhs, then no one will agree, right? Within
Yes.
limit, within
Yes.
limit. Range is important, correct?
Okay.
That's why
Okay.
only the thing is conclusion. See, concrete and steel, you have many factor of
Yes.
safety. That's why nobody will go. Civil engineers go to jail. Correct? Any
Yes.
design
Yes.
failure. Since
Yes.
factor of safety, that's what my teacher thought. That time Sanjeev Reddy sir and all. Correct. But in case of interaction of water hydraulic structures, that is different. Correct interaction. This one very difficult. Sometimes hydraulic failure rate is
Yes.
very high.
Yes,
Correct.
sir.
Mm.
Thank you very much, sir. And
I
excellent.
really sorry. I could win a 19th. I could have give more. Correct. Is there any standard for defining number of hidden? No, that one number of hidden evidence. See, that's why nowadays you keep on add. Correct. If you give 10 bars, I cannot see whatever enough. Suppose you reach target, that's enough. Correct. That's enough. We can see. But hidden neurons, cascade correlation, keep on adding. Then you can see how your output. Correct. Once I get A plus, I'm happy. I will not complain. Nowadays, how our students, if they don't get, that they will make hidden practices, right? They will go ahead. They will tell this guy not given and all. Luckily, you people are happy. Maybe someone final exam here. My headache. If anyone fail, directly it will come to. So no hidden practice. Direct it. Correct. Okay, thank you, sir. You have good question. Hidden, Nuran, and how you are dividing data always. Sometimes 80% training. If you have less, sir, less data, you can give 80% for training, 20% testing.
Yes, sir.
Okay. That time. It's based on limitations, sir. That's all. Correct. How much data? Yeah, every time I cannot conduct right data. Then my labor also don't listen. When I worked in Pune, they say you will get promotion, you will become director. Yeah, of course. After another 3 years, I will become full professor. Then please suggest me if you have any PhD type examinations. I'm happy to. I always do with what Nagarjuna University and Guntur and all. I'm happy to anyone as external examiner, collaborations, anything. Please, I'm welcome since I become head recently here. Okay, outside working another so many challenges you all aware. Correct. Even I cannot survive in Delhi. I cannot survive in Pune and all. Even I cannot, in Anna University. Within 1 month I moved. Okay, our place is our place. Correct. Always local is local. Correct. Okay.
Sir, one more question, sir.
Yes. 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 Please, sir. Yes, sir.
When do you satisfy that this much amount of data is sufficient? Like based on R square value or MAE or what is
Yes,
that?
sir. Normally, see, yes, good question. R square, once you got R square, you will get. And another thing, if you plot, under or over predicting, correct?
Yeah.
Scatter plots. You
Yes.
saw, right?
Yes. Yes.
Clearly. Whenever your students want to cheat, if I want to cheat, you will easily, my supervisor, he will ask, run in front of me. Correct. That's why
Yes.
I at Bombay, right? Always our students very smart. They want
Yes.
to manipulate. If you draw, I will draw perfect line. But I did not hide anything. Whatever underlying. If I say in case of width of score, I cannot get correct lateral energy dissipation. If I want hit, directly hit in front of. But if you want side want to hit means I can go the other side, right? So that is the thing. And some beautiful learn I Parvati dam film and all. One is you change dam axis. Another one, my boss told with nature we cannot play, sir. That is the one answer.
Okay.
Nature is nature. Anything correct. Nowadays, see another landslides I saw and all. That also, if you have data, we could work each other. No problem. Landslide
Yeah.
data. Many I saw in Vijayawada. Somewhere I saw in Tamil Nadu. Landslides very dangerous, right? Everything.
Yes.
Due to
So,
rainfall erosivity, correct. That the every area I worked. You can go to my Google Scholar. Anything you want to, you can shoot an email, even official or my one.
yeah. One
We
last
can
question
collect
from
any
my
data. Yeah, tell
one
me,
last
sir.
question from my side, sir.
Yes, sir.
Is there any work going on in the direction of this disaster reduction, risk reduction, sir? Using these ANFIS, SVM, and GEP, etc.
Yes, many
Okay.
using what happened last year. Our
Because
one
some kind
North
of
India.
prediction.
Right, sir. North India. Right, North India. What will happen in Badrinath and all. So
Okay.
now we are all aware. If ice spreading, if melt, see what happened. See, you saw that Kedarinath movie also, perhaps correct. Okay,
Okay.
it's shown clearly, right? some more than Shiva temple, the flood level. So such a data means almost many geographers from UK and all, they warn already global to warning that this, and many data they use soft computing also. I don't know whether paper got accepted or no. This Iit Roorkee people and some other universities, the
Yes, sir.
Delhi people, they using, sir, mostly.
Yes,
Now
sir.
after become head, if publishing very less, and my student doing, turbines and also something, power generation one for small island development he's doing many
Very nice,
things
sir.
nowadays.
Very nice, sir. Thank you, sir. Thank you, sir. So,
Thank you, sir.
any questions from audience? Any question from participants?
Yes,
We
please.
have few more.
Chatting they asked.
Yeah.
Yes, sir. Yes, sir. Paul, sir. Yes, sir. I could not hear. Hello. Gansham Paul asking something.
Nothing,
Could you
sir.
ask
Nothing.
him? No, I did not show the bridge peer scores and all, that one common, right? Many bridge peer scores, bridge peer. If peers, always debris flow and all, the bridge will collapse. Many, But our importance, you all aware Srisalam Dam and all, our one latest, this 6 months how it gone. So God save us, correct? Anything bad, correct? But we cannot avoid almighty flood, sir. That is my answer. If anything, we can't. This is the nature. I really felt very bad. I really don't know about Vijayawada. That one, whatever happened. Okay, I saw really
Yeah, yeah.
three,
With your
four,
last words,
three, four.
I have another question arising in my mind. So, most of the nature processes are stochastic and unpredictable.
Exactly.
But how?
Stochastic nature. That's
Yeah,
why stochastic nature and risk there.
yeah.
Yes,
How
sir.
these
Yeah.
neural networks, ANFIS, SVM, GEP may
That's why they
help?
capture, sir. This one what
Okay.
technique, random input to random
Okay,
output.
random.
Whenever, yeah, whenever problem is poorly defined.
Okay.
Otherwise, see, if I want to come daily coming, if risk how we don't
Yeah.
know what is happening share market anything. Means some unanswerable questions,
Uncertainty.
correct?
Uncertainty.
Unanswerable questions.
Okay.
Whenever problem poorly defined, then only go for. I asked my supervisor. He say when you are in water, I don't know where the HOD sir is there. If I want it won't it. You hiding, correct? That's why
Yes, sir.
hidden process, right? Correct.
Yes.
You as a HOD, how many complaints you will receive? Some anonymous emails you will receive, some directly. Correct.
Yes.
If
Yes.
they have influence, they will say no. You need to pass the student. Why? The weightage came. Correct. Phone came from
Yes.
big boss. So you
Yes.
must pass. If someone, if normal, so you don't worry, right?
Yeah.
So the nature, we as a civil engineering, we are daily dealing with nature, correct? Which
Yes.
soil, which nature, rainfall, erosivity, everything is nature. Because of civil engineer, that's why our one Royal Civil Engineering, correct? Not like others, correct?
Yes.
Still existing civil engineering.
Good, sir. Very good, sir. Excellent lecture. I'm very much thankful to you, sir. Sir,
I also very, yes, sir, tell me. Yes, sir.
Leela Prasad, sir, will you propose vote of thanks or shall I do, sir? Leela Prasad, sir. Okay.
Sir, sir, I will
Yeah,
continue.
one second, sir. One second. Someone asked
Your
Viren
wish,
Chandra.
sir.
So, sir, one second.
If you
Someone
want me
asked
to tell, I'm
question.
ready, sir. Okay,
Question
sir.
asking. Overfitting. How? If you do this one, you can see the next program. You will go sometime up down, sometime up down. Then you will understand right easily. You say, this guy some manipulating. So overfitting. Normally, when do Levenberg this one fastest algorithm. See, that's why he told map propagation if used, it will avoid overfitting. We say right, we'll say in Telugu, he doing ati, correct,
Yes.
overfitting. That kind of
Yes.
sometimes you need to train, right? You need to. That's why we do normalize data and do correct. Otherwise, you cannot allow anyone can wear in your class, correct? Lab dress and all, civil engineering students, mechanical and all. Okay, sir. Yeah, go ahead. Thank you very much.
Yes.
Sir, good
Sir,
evening,
I'm
sir.
ready.
Yeah, Kiran Kumar, sir, ask.
Sir, myself Kiran Kumar from Anil Neerkonda Institute of Technology, Visakhapatnam, sir.
Yes, sir. Go ahead, sir.
Sir, very nice presentation, sir.
Yeah.
Sir, you showed some technician, sir, the ANN, ANFIS and SVM, sir. That is for if the relation between dependent and independent is non-linear, then
Exactly.
we are using this
Exactly.
type.
See, that's why I said Dopta score is function of so and so, so and so. Always you need observed data. That's why you say nature based observed or any physically conducted. Yes, yes. Go ahead, sir. Go ahead.
Suppose if it is linear relation between dependent and independent variable, generally we are using multiple linear regressions.
Exactly. If non-linear relationships, correct. See, I show you non-linear. See, if we pay more, see, HODs are paying more, then I will happily come anytime. Correct. If you pay less, what will happen? That's what happening in case of score, right? If a boulder very high, correct, non-linear relationship. I show you, right? How our lip angle. Sometimes linear, sometimes non-linear score in process. Correct. Agree?
Yes, sir. Yes, sir. Yes, sir.
That's why
Sir,
we say runoff, rainfall, linear relationship, right? Although you are doing, first you will do, then you use logarithms, right? Remember logarithms, then you will find out R equal to AP power BP. Then you are making linear, but your original equation state discharge relationship, how it coming? It's showing some power, correct? Remember?
yes, sir. Yes, sir.
That's one.
Sir,
Thank you,
suppose
sir.
if it is linear, sir, we are using MLR. Sir, in addition to that, any other modeling technique is there for linear
Yeah, that's why
relation?
I was telling this one very bold, sir. This one very bold. Nowadays, my students and all they go very, very advanced. You go export, gene experiment program, GP, even beyond gone. I don't want to spoil my eyesight. Why should I published 206 papers, not 101. you know, for me enough. And recently, my student one, you can see in water discover paper, Italian, my student, he published very nicely. See, when your trees there and ocean water coming and all. Okay. So sometimes always you find non-linearship only in life also same, right? Nowadays
Yes,
everything
sir. Yes, yes, sir.
everything mosam
Yes,
in Telugu.
yes, sir. It's
Correct.
non-linear only, sir. Yes,
Mosam
sir.
means risk, correct? Everything
Yes,
you are
sir.
taking risk. Everything you're taking risk only. So you will
Yes.
get even your students whether if it study civil engineering we will get job or no. No, we are taking
Uh,
risk only, right?
Sir, another last question, sir. Sir,
Yeah.
suppose if we use MLR, we get some dependent variable equal to A1 x1 plus A2 x, some
Yes,
intercept will be.
once you do equation, sir, you will get
Sir,
powers, those powers. Then you will easily understand, oh, this is the very important parameter. That's why I showed you, right? Maybe you missed
sir,
that one during my
suppose if
lecture time.
yes,
Tell
sir.
me.
Suppose if I used ANN technique, directly we get some R square, RMSC values, and
Yes,
MSC
yes,
values,
yes,
sir.
yes. Everything, sir. Again, what will happen once the trained model you give observed data, predicted data, you make
Yes,
table, then you need to use all this in Excel or anywhere formula. Some software GP it will show directly to you.
yes,
Your
sir.
R square, RMSC, everything direct, sir. Nowadays, this one neuro solution something came. You no need to do. You ask your students just right click. It will show how much R square and all. Everything you will get. You will decide this one fitting. So they
Sir,
show many new.
yes,
This
sir.
one
Suppose
even
if
old
you want,
maybe.
if
Yeah.
you want to predict or estimate
Ah,
some discharge or anything
yeah.
runoff by using
Yes.
MLR, we get some amount of means 300, 200
Huge
meter to
error, right?
600
Huge
like
error.
that.
That time don't go. That time if you show, if you submit paper, editor will throw away in dustbin. They will say the huge error.
Yes,
That's
sir.
why
Yes,
you
sir.
can. I used GP programming that time. I used GEP also used GP also means gene experiment programming, genetic programming. Both I used. Okay. Many
Finally, we
came, sir. Yes.
finally we compared by using RMSC, MSC only, sir.
Yeah,
That is
sir, I study polarity engineering college that time. You will ask if I go for interview, you will ask what you will ask. Are you first class honors, first class distinction? Nowadays, what they will ask semester wise GPA 4.0, 5.0, correct? How
yes,
you
sir.
evaluated me because of my marks, correct? Agree?
Yes, yes, sir. Yes, sir.
This one how you were evaluating, correct? My
Yes,
teaching good sometimes, my presentation everything good, my explanation is very bad. Then how students will give? Here I worked in various countries, Fiji, Malaysia, Saudi Arabia, everywhere. So sometimes if why I am happily present to you, since you understand my language, my accent, correct? Agree?
yes, sir. Yes,
How
sir.
you evaluate me today? Correct. I
Yes,
show
sir.
some photographs.
Yes,
And also I show some importance. Correct. Everything measuring, sir. If you get good score, then you will say you are good teacher. You are passing rate. Correct. So how HOD will sir or principal will say very good, Dr. Kiran. They say your passing rate is very high, strike rate very high. Correct.
yes, sir.
Today Dravid put very good score. Correct.
So yes.
That's all.
Yeah,
Everything
already
number.
HOD sir,
Yeah.
already HOD sir covered this stick. How much data is required? Sir, I go through some papers. Someone using 80%, 18% of data for training, 20% for testing.
Exactly. That's what I
Sometimes
told,
they are
man.
using 70-30.
Uh,
Someone
uh.
using 50-50. Someone using 60-40.
That one no
So
problem. See, again, how you are getting your results, correct? How you fixing, extracting data division, very important. MATLAB suggested 50 use training, but I always told you range. your range, whatever there, then again don't use in testing or validation. Okay. Sometimes 75-25%. All you can see my papers. Depends your range, sir, how you conducted experiments. And also sometimes 50-25, there is no harm. There is no actually no guidelines. How you are getting your results, R square, root mean square, and all. Once you satisfy, otherwise what you will do? You need to want to do more discussion. You want, right? You can do validation. You can do testing. Okay.
Okay, sir. Okay. Thank you, sir.
Okay, sir.
Thank you so much.
Sir, I need to go meeting. Already 10 o'clock.
Thank you, sir. Thank you very much, sir. Let me.
I totally forgot. While
Yeah,
talking, Kiran sir,
I'm very much thankful to Professor Haji Muhammad, because we have troubled him. Actually, today's session was actually to be given by Kailash Chandra Tiwari from Australia, but because of his health issue, we have requested Professor Haji Muhammad, and he's very kind enough and kind-hearted, and he accepted our request and given excellent presentation, even though he's, in spite of his busy schedules and all. Thank you very much,
Yes,
sir. We will be in touch with you, sir. We will contact you in future also. Thank you very much. Thank you very much, sir. Thank you.
thank you.
So,
Okay, bye, sir. Okay.
bye, sir. Bye, sir.
Namaskaram అందరికి.
Namaskar, namaskar. Thank you, sir. Lela, sir, close చేసేయండి.
Thank you.
On behalf of all the participants, I would like to express a sincere gratitude, sir, for your insightful and enlightening presentation on the application of soft computing techniques, especially in hydraulical engineering, sir. And mainly one thing we have observed, sir, your expertise and passion for the subject matter were truly inspirational, sir. Thank you so much. Thank you once again for sharing your knowledge and experience with us, sir.
Yeah.
We look forward to future opportunities, sir, to learn from
Yes,
you.
please,
Thank you
please
so much.
collaborate with me. I also thank you to you for giving this opportunity. Actually, see, 1.5 hour normally, I never more than 45 minutes, but today, as participants also very happy, and you may understand, I don't go that much fast. What to do? Correct, semester wise, we need to go fast, and I have another meeting. I need to run to my director.
Yeah,
Okay,
yes,
thank
sir.
you very much.
Thank you,
Bye,
sir.
sir.
Thank you.
Bye.
Thank you.
Good evening.
Thank you,
Good
sir.
evening. Good evening to all. Okay, 10 o'clock right here. Bye.
Good evening, sir. Am I audible, sir?
Ganesh, you are audible, and invite the
A
next.
warm evening to everyone, speakers, head of the department, and dean of academics for Ramchandra College of Engineering.
Yes.
I'm going to introduce Dr. Barnidharan Garu, working as assistant professor in NIT Tadapalligudem, Andhra Pradesh. Welcome, sir. A warm welcome, sir. Sir, coming to sir profile, sir has done his graduation in RVS College of Engineering and Technology, Chennai, and sir has done his post graduation from Center of Environmental Study, College of Gindi, and sir has received his PhD from civil engineering from IIT Delhi, and sir has a total experience of 8.5 years of teaching and research, and sir has interests on research insights of effects of emerging contaminants of environmental specific area, which includes nano and microplastics, and expertise research about release of nano microplastics from productivity, and assessing environmental risk of microplastics, and microplastics as carries from co-pollutants in environment, and the total impact of assessment of nanoparticles and microplastics in life cycle assessment. Okay, thank you, sir. Hello.
Yeah. Sir, Professor.
Yeah, thank you. Thank you.
Barnidharan.
Yeah, thank you, Dr. Ganesh, and as well as the civil HOD.
Yes, sir.
Style project.
Welcome you, sir.
Yeah, thank you.
Yes, sir.
I hope the slide is visible, right?
Yes, sir. Yes, sir. Visible,
And
sir.
you can see the slides getting changed, right?
Change, yes, sir. Full screen as well as changing. Yes, sir.
Can continue.
Fine.
Thank you.
So, good evening, one and all. So, So myself, as introduced by Dr. Ganesh, myself Bharanidharan, Assistant Professor in Department of Civil Engineering here at NIT Andhra Pradesh. So I'll take you down today with respect to the role of civil engineers in disaster risk reduction. So myself, bachelor's from civil and then specialized in environmental. So I will take a different look at how disaster can be assessed, and then as well as what are the emerging risks that we have in and around in the environment. So I think the previous speaker spoke with respect to a different topic with respect to water resources engineering, and then I am here to give a different flavor with respect to environmental engineering. So moving on with respect to disaster risk reduction. So this is one such thing, mainly to have an aim of reducing the risk or minimizing the risk in case of a disaster. So if a disaster happens within a no matter of time, be it a cyclone or be it a flood or be it a landslide or be it a forest fire. So how the risk to the livelihood of the people can be reduced by taking appropriate actions. So more or less, disaster risk reduction is more correlated with respect to the risk management. How do you handle the risk in case of a disaster that happens within a short duration of time, and then otherwise within a no matter of time, or where the disaster can't be handled with respect to the mankind. So the main thing is, one such thing is that minimizing risk by having appropriate strategies, so that with respect to risk, the mainly with respect to the human lives, how best that it can be saved. And then the second thing is that the economic dependence with respect to the humans, so how best that it can be managed, comes into picture when we are discussing about the risk reduction. So why to focus on disaster risk reduction is mainly with respect to the loss of lives, as I have already said that, and within no matter of time, the life changes. So with respect to floods, even if a flood occurs, especially take the where the last speaker was speaking about the Vijayawada floods, very recent floods, where within no matter of time, water got stagnated, and then if you are having certificates down your home, so all the certificates might have went, and then again the life takes a U-turn. So again, loss in property, and then loss in again economic status with respect to equipments or with respect to products which are there in commercial establishments. Again, all it goes off with respect to a disaster. So a disaster can be of anything. It can be a landslide, where it can happen anywhere in the northern part, or otherwise with respect to flash flood in a mountainous region, or where floods due to heavy rainfall. And with respect to disaster risk reduction, again, two different factors come into picture. That is socio and economic progress, how best that it can be handled. So one such thing with respect to disaster risk reduction is disaster can't be prevented at any cost, be it man-made or with respect to natural, but the risk can be reduced. So how best the risk can be reduced is a question in front of us. So as it is inevitable to stop or prevent the disaster, we will not be in a position to stop a cyclone coming in, but still we can have or raise precautionary steps, warnings, or etc., so that the people in and around the place can move on to a safest place, and then the total risk to the human can be reduced. So with respect to disaster risk reduction, so as I've already said that it is with respect to loss of life, economic as well as social impact onto with respect to the risk. So with respect to disaster risk reduction, one more thing is that what happens whether it in case of a drought, it can be a flood, it can be a cyclone, it can be an earthquake, it can be a landslide, and it can be a tsunami. So with respect to India, all these things are very common. With respect to drought, how best that it can be sorted out, one such thing, or what are the measures that it can be taken in order to foresee the drought for how long it can go, and then what are the mitigation steps it can happen. And then with respect to floods, how best the people can be evacuated from the low-lying areas. With respect to properties, how best it can be saved. And then with respect to cyclone, the classic example of say with respect to the state which has faced numerous cyclones, take the case of Odisha, where in the past, in the last 2013 or 19 cyclones, they had handled it very efficiently, so that people were evacuated in large number, and then they were provided shelters, so that at last, though there were impact onto the properties with respect to civil domain or mechanical, but still the risk associated to the human lives were drastically reduced. And with respect to earthquakes, still within no matter of time the earthquake strikes, but still what best it can be done, what are the strategies, and then what are the evacuation points that it can be there, and then how best the system can be designed. All those things can be part of strategy to minimize the risk. With respect to landslides, again, with respect to cloudburst or with respect to a heavy rainfall forecasted over a specific region, the best thing is about the warning, how best the warning system reaches the people, and then how the people can be evacuated. With respect to tsunami, though it has striken once in Indian coast, but still once after the case of tsunami, there were several buoys that were installed onto the Indian Ocean in order to assess the height of waves as well as the earthquake happening underneath the Indian Ocean. So moving on, the main components with respect to disaster risk reduction is one such thing is mitigation, followed by preparedness, response, and recovery. So these are the main four things with respect to the management or handling a risk. So one such thing is mitigation. So mitigation is the first step, that always its prevention is better than cure. So it happens, the action before the event. So how best the event can be managed, or what are the actions to be taken before an event. Event can be in case of, it can be a heavy rainfall, or it can be a landslide, or it can be a cyclone, etc., etc. So again, mitigation is a phase for reducing all the risks associated with it and impact caused by the disaster. So that is also one such thing. And there are several steps associated with respect to mitigation. So to name a few are vulnerability assessment, risk assessment, as well as hazard assessment. And then to name a few, again, community engagement, as well as planning and infrastructure work. So again, as I mentioned earlier, mitigation corresponds to the action before the event, before the disaster event. The event here I'm mentioning about is nothing but the disaster. And then again, the next thing is about the preparedness. How best that we are in a position to prepare, and then what are the planning to go, and then how to respond in case of a disaster. So for example, it can be a warning system, or it can be an emergency exercise, or you can think about a training exercise. The classic example is where most of the firemen will give a drill, or otherwise in railways people will do a mock drill where they will plan for an disaster like an accident, and then they will look after what are the practices that needs to be done. So that means that the preparedness in case of an disaster. So again, a logistic associated with the preparedness, technology, as well as the agencies, different stakeholders. So whom to reach, and then at that point of time, you need to have a checklist so that the risk can be mitigated. Provide information and tools to citizens. So again, this is one such thing: information to citizens. What are the steps that are being taken, and then what are the preparedness, whom to contact, etc., etc. And then the next thing is that the response. So once there is a disaster, and what is the response? So already there was a big plan that has been went into, and then the strategies, and then etc., etc. But the risk, or otherwise the once after the disaster, what will be the initial action towards that corresponds to response. So for example, what are the evacuation points, and then how best the shelters needs to be provided in case of an accident. It can be a road accident, it can be a train accident, etc., etc. Or else in case of a flood, or otherwise if flood inundation happens in a low-lying area, how many people needs to be evacuated, where they needs to be sheltered, and then what are the kitchen arrangements or food arrangements, preparatory arrangements, etc., etc. So those are all nothing but response. And the next important thing about the response is nothing but the search and rescue. So you need to, because after disaster, you need to keep on searching. So how best that you can still recover lives within the disaster. And then mass care, because with respect to quantity, and then with respect to manpower, a huge manpower is required, and then how to cater them, and then logistic response, and the initiate recovery. So one such thing is that once you have tabled everything, So you need to have the recovery part. So recovery in terms of getting back to the normal condition. So once the disaster has struck, it is very difficult to get back to the normal condition within no matter of time, be it uh, uh, with respect to floods, or with respect to cyclone, or with respect to landslide. But still, what needs to be done in order so that the community bounces back to its normal condition? So one such thing is that, for example, again, you take the case of flood. So again, temporary housing for a short duration of time, and then how best the streets or the places can be cleaned, and then the debris management comes into picture, return of essential services, how best that needs to be given to the people or the community who are there. And then temporary housing, as I have already said, the temporary shelters, economic assistance, as well as insurance claims for building, as well as. So this is the classic example where you can correlate with respect to a flood. In case of a flood in a city, how many people to be evacuated, that is after to be evacuated, shelters, food, essentials, medicines, as well as the recovery or otherwise the insurance claim for the properties. So with respect to, though it looks very simple, but still a lot much of effort needs to go with respect to all those 4 stages in order to avoid a greater risk. So even the messages that we get nowadays in the mobile, where you might have a chance of strike at your place. So that is also one such thing where in order to reduce the risk. So the government gives a disaster management authorities there, they circulate, and then they forecast that there will be heavy rainfall or the thunder activity at a specific place, and then they circulate the message. So that is all about the preparedness, and then the planning, and then how to mitigate the risk. So with respect to strategies to strengthen the disaster risk reduction, so so first thing, it needs to be like these disaster risks are mapped with sustainable development goals. So one such thing is that I will come to that later on. So with respect to the framework to, or the strategies to strengthen the disaster risk, there are 7 key factors. So that comes from the Sendai framework. So and then this needs to be adopted, or this is in force till 2030, where all the people all around the countries have agreed to follow this. One is global disaster mortality, in order to follow those 4 steps, that is mitigation, preparedness, response, and recovery, so that the mortality comes down in case of a disaster. And then the second thing is that substantially reduce the number of affected people. If you have a pre-planned setup for mitigation as well as preparedness, obviously the number of affected people will substantially come down. And then as well as the third thing is about economic loss in relation to gross domestic product. So one such thing is that how best that you can able to reduce the loss of properties. And then fourth thing is damage to critical infrastructure and service disruption. It can be a gas line service, it can be a water line service, it can be a sewer service, it can be of anything. So substantially reduce the impact of the pipe or otherwise the network that is already established, and substantially increase with these strategies, or otherwise with this preparedness, you can substantially increase the where with the help of strategies, you'll be in a position to mitigate the disasters which are there. And then international cooperation to developing countries, that is one such thing. So again, with respect to technology transfer that happens in order to reduce the risk. In case of cyclone, this happens where different countries coordinate and then track the position of cyclone, and then they issue warnings. And availability and early access of warning systems and DRR information. This happens with respect to earthquake, mostly the natural disasters, be it earthquake or tsunamis. So again, as it comes from the Sendai framework, so the disaster risk reduction again corresponds or gets correlated to some of the key sustainable development goals. We call it as SDGs. So as there are 7 targets, so which are named as or listed as A, B, C, D up to G. And then those are related to different goals which are listed in sustainable development goals. So one such thing is that with respect to no poverty, and then the second thing is sustainable cities, and then with respect to the climate action. So all these 3 things can be tackled with the help of the strategies that we prepare for disaster risk reduction. So with respect to no poverty, again, in case of a drought or otherwise in case of flood, if you are prepared, then still you will be able to save the community as well as save the resources. And then sustainable cities, the cities should be resilient in such a way that it withstands the infrastructure withstands the disaster where the city is involved, be it with respect to floods or with respect to any other natural calamities. And then climate action on a global level, where you will be able to share the data, and then you will be able to reduce by taking the actions locally, wherein the climate change can be reduced. So all these things are correlated with respect to the sustainable development goals. By if you follow the Sendai framework, where the 7 points, or otherwise if the disaster risk reduction has been meticulously planned and framed and then followed, then we are inching towards the sustainable development goals, the key sustainable development goals. So moving on, I'll give you an example with respect to disaster risk. So till now, we have been discussing with respect to natural disasters, be it landslide, be it floods, etc., etc. So one such thing is that I'll take a slightly different flavor with respect to plastic pollution. So plastic pollution is one such thing that has been inevitable at this point of time, where a developing country like India still finds it's very difficult to manage the plastic that gets generated as waste, and then still finding ways to meticulously manage the plastics. So as all we know, this figure is very relevant. We have been crossing several bridges, and then this is one such view where we can say that the plastic at last ends in the surface water bodies, or at last the ocean. So through surface water bodies, at last it reaches the ocean, and then they get dumped, or otherwise they get piled up. So a study states that by 2050, there will be more plastic than fish in the oceans. So that is one such thing that is really to be worried about. And then again, in a simpler terms, so by 2050, still we have 26 years to go. In different terms, around 22 million kilograms of plastic gets into the ocean. So now you will be able to correlate with respect to the volume of plastic that gets into the ocean. It can be through any form. It can be through water, it can be through air, it can be through any other form, but still at last the end place of plastics in environment is nothing but oceans. And with respect to plastic management, it's still so as again, whether have we prepared, even though it is being used widely, but still it has not been those 4 steps with respect to mitigation, preparedness, recovery, it has not been followed. And then with respect to plastic, it's still a disaster because no proper management has been done, and then these plastics outlet into environment gets modified and then keeps changing from one form to other form. So with respect to plastic pollution, so we might have come across this term called country-wise overshoot days with respect, as we are coming close to 2024, wherein this is one such chart which states that where each country, where the date specifically Feb 11 for Qatar, April 1 for Netherlands, September 4 for Algeria, June 20 for Argentina. So those are the dates. Beyond that, the country is not in a position to manage its own waste. So whatever, assume that if it's June 23rd as Paraguay, so beyond that, whatever the waste it gets generated, Paraguay is not in a position to handle, and then all these waste gets accumulated in the environment or otherwise in the ocean. So for us, it was there in April 23rd as a date for India, which is not mentioned here. And then for a whole world, it has been kept as September 22nd. So with respect to that, so whatever that around the globe, beyond September 22nd, whatever the plastic that gets generated is not in a position to get managed in the environment. And then at last it ends up as a waste. So with respect to plastic pollution, so still it is a clicking disaster. So again, as it though disaster with respect to natural, it strikes within no matter of time, but still the man-made disaster, it takes, when you look in decades, it is no matter of time. We are accumulating plastic like anything. And then still plastic is one such disaster that it is like it's a ticking time bomb. So where this chart gives you worldwide mismanaged plastic weight with respect to 2025, and then India stands something around with respect to whole South Asia, we are around something 11%, etc., etc. Still very high when compared to the other rest part of the world. So moving on, so with this, again, with respect to plastic, how to assess the risk, etc., will be my future course of discussion. So, as all we know, plastics comes from a Greek word, and then there are different types of polymer. One such thing is natural, semi-synthetic, and synthetic. So, natural, the simplest example is nothing but the rubber that we get it from the tree. Semi-synthetic, again, natural plus synthetic, and synthetic is nothing but the polymer that we keep using on a day-to-day basis. So it can be polyethylene, it can be polyethylene terephthalate, polypropylene, polystyrene, etc. So as I have already said that the volume of plastic that gets produced, as it's keep increasing, again, the volume of waste that gets generated also increases. So with respect to plastic production, there is a linear increase in plastic waste generation within the earth. And then, though when we compare with respect to the rest of the world, or otherwise with the developed world, the content of waste generation is very, very less with respect to per capita waste generation. But still, as a developing country, we need to worry about the waste that we get generated, and then how are we going to manage the waste. So to give an overview, so I'll just take you example with respect to polyethylene, as well as high density polyethylene, polyvinyl chloride, low density polyethylene, polypropylene, polystyrene, and others. So the numbers inside the arrow marks or recycling arrow marks states that how easy that it can be recycled. So be it polyethylene terephthalate, it is commonly recycled. It's high heat resistant property, clear, hard, tough, microwave transparency, and solvent resistant. So that is one such thing. High density polyethylene, we have been using it for pipes, etc., etc. Polyvinyl chloride, most of the conduits that we used is nothing but polyvinyl chloride. Low density polyethylene, so for specific substances which needs to be tough, durable. And polypropylene, most of the food sachets that we get now packed is nothing but polypropylene. Polystyrene, again, foam based polymer, and then others which are difficult to recycle. So to name a few, plastic sectors keeps changing. So, but to look into, packaging dominates a lot, and then followed by building construction, followed by automotive, followed by electrical and electronics, household, and then as well as agriculture. So within packaging, normally it is very easy for us to correlate the amount of packaging that we had with respect to 5 or 6 years back with respect to an Amazon product, and then what are the packaging that we receive now is one such thing. With respect to packaging, it can be of anything, which we have already seen. So again, whether the plastic remains as a plastic is one such big question that is there. So as I have already listed out, with respect to plastic disaster, these plastics gets carried away through the source of water to the oceans. So that is one such thing. It can be as highlighted, it can be with the help of wind, or it can be with respect to the water, etc., etc. And then these plastics gets broken down with the action of wind or abrasion, or with respect to UV degradation. So with respect to plastic breakdown, it can be of macroplastics or microplastics or nanoplastics. With respect to size, macroplastics are being classified as particles of size greater than 5 mm, microplastics of size 5 mm to 0.1, and the nanoplastics of size less than 0.1. It can be of any shape. Given the shape, it can be a fragment, it can be a sphere, it can be irregular particles, films, and fibers. And then it can be of any color. So be it black, green, red, we have plastic products of all colors, so nothing to worry about it. So why to discuss about these plastics? Are we really worried? Because already we have generated enough waste, but still as it gets keep on piling up. So whether really we need to have a concern about this? Yes, we do need to have a concern, because this also gets it, and then the risk of having these in our day-to-day life is getting more and more. So with respect to different shapes, it can be from the virgin material, or it can be from the recycled material. So it can be based upon the source of product. Either it can be classified as primary, secondary. Primary is nothing but manufactured for a designated purpose, and then secondary is nothing but it gets broken down from the macro particles. It can be, again, the source, it can be mainly from a land-based source, and then all the land-based sources leads to ocean-based sources. Apart from that, the activities that happens in ocean, be it mainly with respect to the marine vessels or the fishing gears, or otherwise the littering that happens all along the coast of any country. With respect to improper plastic waste management, again, the plastic that gets littered off gets back into the ocean, and then again comes back. Again, it stays back onto the coast, and then it gets degraded, and then at last it spoils the coast. So with respect to land-based, there are different walks, be it from the synthetic polymers that we use as textile products, be it the packaging materials, everything gets onto the land, into the air, as well as soil. So you won't believe that. So with respect to 1/4 of the fish that in the ocean has been contaminated with plastic. So again, as I already said, that in the year 2050, you will be ending up with more quantity of waste, of plastic waste in the ocean than the fish. So again, with respect to the recent study where 1/4 of the fish contains plastics. So again, with respect to the growing years, the risk of having these plastics into our human chain or into our food system is very high. So with respect to the pathways, there are different sources. To name a few, where we have already seen with respect to the synthetic materials, textiles, as well as the tire dust, the pellets with respect to industries, etc., etc., the fishing nets. There are several sources in the environment. And then apart from that, again, the microplastics get into the environment, and then the fate, either it can be in the water or either it can be in the soil. Again, with respect to the wind, is a big question. So otherwise, the risk in which these microplastics possesses to the aquatic organisms, to the organisms in the soil, as well as to the living organisms, is a matter of question. So in order to quantify the risk, so a study needs to be conducted, where again you need to have a proper methodology to carry out the study and then assess the risk. So there are different, as I have already said, that there are different pathways as well as the degradation that happens for these plastics in the environment. Excuse me. It can be based on the photo degradation with respect to the action of sunlight. The UV rays breaks down the macro particles and then results in microplastics. And then thermooxidative degradation, again at a moderate temperature, these plastic particles gets broken down. Hydrolysis based upon the action of water. Biodegradation with the help of organisms, and thermal degradation, again molecular deterioration but at a high temperature. So in case of a fire event, and then what happens to these polymers. Exposure route to the humans, it can be either through soil, water, and air. And then again, with respect to soil and water, either how does these particles or plastics gets into the system? Either it is through inhalation or ingestion is one such thing, or otherwise by oral intake. So with respect to oral intake by drinking water is one such thing, because as of now, the recent study has said that the packaged bottle drinking water is also at a high risk. So you possess a risk by consuming that water, and then at last you might end up in having microplastics into your food. So that is why it has been classified as a high risk. And then the consequences with respect to humans, it can be, still the studies are there, and the consequences needs to be well documented so that the mitigation can happen at an effective rate. So now you will be in a position to understand that these plastics, which are turning to be a disaster no matter of time, are there everywhere in the environment. It can be there in the atmosphere, in air, because of their small size, it can get traveled, and then it can be there in the soil, and then everywhere. So to name a few, so some people might disagree, so as we have not seen it, and then still is it still really having those in the environment is still a big risk. So yes, there are studies which have documented with respect to their presence in rainwater as well as stormwater. And a recent study in India itself have quantified the concentration or distribution of these microplastics in case of a rain event. So in urban as well as peri-urban was compared, and then it was found that microplastics were directed in case of a rain event. So moving on with respect to disposable paper cups, wherein we consume water, hot water, or otherwise a cold beverage, or otherwise a hot beverage, where we consume, there is a high risk of having these microplastics into our system. And again, as I have already said that, where we will also be looking this as a case study. So the prevalence, and then as well as the the risk associated of consuming the packaged drinking water. So it can be there in the commercial fish. So as the studies have confirmed that these microplastics are there in the environment, and then they are most abundant in the ocean, and then they get onto the fish. And then again, it is there. It has been documented that these microplastics are there in the human blood, and then as well as in the breast milk, as well as in the infants. So not only in the man-made region, but also these microplastics are being present in the remote locations of Earth, be it Arctic or be it the Antarctic. So one such thing is that the ocean currents takes these plastics and then keep moving to the farthest distance, again polluting those organisms which are there in the pristine environment. Again, so these plastics again acts as a vector. That means that acts as a carrier to transport other impurities or pollutants by getting attached onto them, and then takes it to the farther distance. It will be strange to understand that, or otherwise to infer that with respect to the abrasion that happens between the tires and roads are one such big contributor of microplastics in the environment. So we will not be able to even think about from this aspect. So one such thing is based upon the climate. One such is nothing but the speed at which you drive the vehicle, and then the tire, how old is the tire, and then as well as the road surface, either it is how old it is, and then how rough it is, or how smooth it is, and then the road condition. So all these factors contribute to a greater concentration of microplastics in the environment. So it is not only from the land sources, but also with respect to the car. Now, as I have already said, that from the rubber, again, the microplastics can churn out. So in order to get a better understanding, so in case of a rain event, the quantified concentration was something around, the range was something around 15 to 90 items per liter. So that is the way in which the microplastics are being identified or communicated. And then in case of a snow event, the concentration was still greater. So that means that their presence in the environment is high. At the same time, the risk associated with them is still not quantified yet. So as it's everywhere, so I'll make a move. So one such thing is that, again, the 4 steps, be it the disaster risk reduction. So again, here the challenges with respect to these pollutants are, one is how to identify and quantify in the diverse environment or complex environment. That is one such thing.
Prasanna garu, please mute yourself. Mr. Prasanna, please mute yourself.
Yeah, I request the participant to mute. Yeah.
Yeah, done, sir. Done, sir.
Yeah, thank you. So
ఈయనంతా ప్లాస్టిక్ గురించి. ఒక్క నిమిషం ఆగు.